Good morning, students. The topic that we are taking today is about the sequence and series, and here we'll study about the arithmetic progression. Now, arithmetic progression, how do we define the terms A1, A2, A3 and so on? They form an AP when an plus 1, this is equal to an plus t. That is, the next term that you are finding is equal to the previous term plus common difference. D stands for common difference. And here n belongs to natural number. That is, we are talking of the finite series. We have studied about the arithmetic progression in class 10th also, and if you recall, the general term used to be the standard form of an AP used to be A comma A plus t, A plus 2t, and A plus n minus 1 into t. And this here L used to be the last term. And before I start with this, I must tell you that how do we find an? An is a general term, or any term that you are willing to find. So an can be found by a plus n minus 1 into t, where a is the first term, n is the term that you are looking for, d is the common difference. Let's say I have a series, let's say I have 3, 6, 9, 12 and so on. So this is the first term, and common difference is found by taking the difference of two consecutive terms. This is a common difference. Now how will you find the, let's say I want to find 10th term. So this formula will come to our rescue. This says that an is equal to a plus n minus 1 into t. So that is 10th term will be a plus 10 minus 1. In place of a you can put 3. 10 minus 1 into d is also 3. So here this is 3 plus 10 minus 1 is 9 into 3, that is 27 plus 3, that is 30. So 10th term is 30. So this way you can find any number of terms that you are looking for. Now the next thing which I would like to tell you is about the Sn. Now what does it mean? Sn means, Sn is the sum of n terms. Sum of n terms. Let us recall we have AP as A plus T, A plus 2T, and the last we can take A plus n minus 1 into T. So this is the last. Now Sn, the formula for Sn is n by 2, 2a plus n minus 1 into d. This is one of the formula. When you have been given a series with first term and the common difference, and this can be written as, 2a can be written as a plus n minus 1 into t. And this is, if you recall, this is the last term. So we'll replace it by the last term. n by 2 into a plus l. So this is like you should remember there are two formulas for finding Sn, and we have one formula finding the general term. This is that we need in formulas of AP. We'll start with the exercise. We have exercise, this is 9.2 on page number 185, and I'm taking NCERT. Let's start with question number 1. It says find the sum of odd integers from 1 to 2001. So odd integers from 1 to 2001. So here we have been given the first term is 1 and the last term is 2001. In between we have to manage. So the first is we have to think of odd integer. So the first integer is 1, the other will be 3, the rest 5, 7 and 9. what we have to find? We have to find Sn. But before you find Sn, you should know n. So how will you manage n? I told you the finding the last term. We have the formula. How do we find last term? Last term is a plus n minus 1 into d. Now we have this last term is 2001. Okay. First term is, you can manage a is equal to 1. D is equal to difference of consecutive term. That is 3 minus 1 is 2. And last term is 2001. So this value can be substituted in the given equation. So this is 2001 is equal to 1 plus n minus 1 into 2. So this can be simplified. So here 2001 minus 1 is equal to n minus 1 into 2. So this gives us 2000 is equal to n minus 1 into 2. So n minus 1 is equal to 2000 upon 2, that is 1000. So n is equal to 1000 plus 1, that is 1001. 1001 is a number of terms. We have the formula to find Sn because we have to find the sum of those terms which lie between 1 to 2000, and the number of those many terms we have found 1001. And if you use, if you see logically, like from 1 to 2000, we have 1000 are the odd integers, 1000 are the even integers. So 1000 integers are split away and 1 integer is extra. So in totality we'll have 1001. So now here we have 1000. 1 is n. So Sn will be n by 2. We can use this formula. Reason being, we have first term, we have last term, we have number of terms. So n is 1001, a is 1, and l is, what is the last term? Last term is 2000. So S 1001 will be 1001 upon 2, a is 1, this is 2001. So here this is 1001 into 2002. This will be 1001. So we'll multiply, and whatever we get, that will be our answer. So, well friends, we were doing arithmetic progression chapter 9 class 11th, and so far we have done question 1. Now we'll be doing we'll discuss few questions, and you must try questions at home. So our second question is concerned, find the sum of all natural numbers lying between 100 and 1000 which are multiples of 5. So this question you can try yourself. Here are multiples of 5. So starting from 100 to 1000, so we'll find first term. So of course it will be 105. It's between 100 and 1000. So we will not involve 100. Okay, if it is from 100 to 1000, then we can take 100. But between 100 and 1000, then we'll take the next number which is divisible by 5, that is 105. And the number before 1000, which is divisible by 5, is 995. So just try out this question yourself. And here, moving to this question number 3, I'll take question number 3. In an AP, the first term is 2. So we'll just note down whatever are the details given to us here. So this is third question. In an AP, the first term is 2, and the sum of first 5 terms is 1/4 of the next 5 terms. Show that 20th term is minus 112. So here you can see that first term is 2, and it says sum of first 5 terms, that is S5, is 1/4 of the next 5 terms. So how will we find that next 5 terms? We'll write this. So how we come to this conclusion, this is very important thing to know. For example, next 5 term, if you take S5, so the next 5 term will be S6, S7, S8, S9 and S10. Now how to put it in a generalized form? These are the 5 terms. So how to put it in the form where we can apply the formula, because in combination we cannot write them together. So now S5, so we'll just simplify this equation. Here this is S5 is S10 minus this 1 by 4 will shift to the left side, minus S5. So this becomes 4S5 plus S5 is equal to S10. This becomes 5 times S5 is equal to S10. Now just students, recall the formula which I told you, that is Sn was n by 2 2a plus n minus 1 into d, where n is a number of terms, that is how many terms we want to find the sum. So here this is S5, this is S10. For both we'll find S5 is 5 by 2. However, we have been given a is equal to 2, but we would like to put a as it is. We will not put the value here, value of a, till the time we get back the simplified expression. So this is 2a plus n is 5 minus 1, d we don't know. So you will write 5 by 2, 2a plus 4d. 2 can be taken out. This is 5 by 2 into 2. This is a plus 2d. This cancels. So this is S5. Similarly, we can find S10. S10 is 10 by 2, 2a plus 10 minus 1 into d. So here we continue. So S10 is, so here S10 is 5 into 2a plus 90, and the expression, the expression which we were having, it was, let me simplify कर लिया था, 4s5, sorry 5s5 is equal to s10. So 5s5 is equal to s10. We'll put the value. S5 was, it was 5 times a plus 2d, and S10 is 5 times 2a plus 90. So what we will do, we'll try to simplify it first. So here we'll just to simplify, this cancels. Okay, now next is 5a plus 10 times d is equal to 2a plus 9 times d. So we'll just take the difference. So this is 3a is equal to, here this becomes minus, like minus 10d plus 9d. So 3a is equal to minus times d, or d is equal to minus 3a. A was 2, so common difference will be minus 3 into 2. So what was the question? The question was, find out the 20th term. The question was, like, our purpose was to find the common difference and the first term, and the question was, find out the, show that 20th term is minus 112. So we will recall the formula of general term, that is an, this is a plus n minus 1 into d. A is 2 and this is 20th term, so n is 20. So 2 plus 20 minus 1, d is minus 6. So this becomes 2 plus 19 into minus 6, that is 2 into minus 1, sorry, 2 plus minus 114 minus 11, and hence root. So this was the thing that he wanted to prove. Now we have very important one more question, like I would say that you must try this question 4th, how many terms of the AP this they are needed to give the sum minus 25. So please try out this question yourself, and I'll just take this question 5th. Okay, I'll take 5th question, and then you can give try for 4th and 6th. So I'm taking 5th question. It says, if in an AP, if pth term is 1 by q, so whatever is given we'll just note down. This is question 5th. We have been given that pth term is 1 by q, whereas qth term is 1 by q. So we have to prove that sum of first PQ term is half PQ plus 1 where P is not equal to Q. So the important thing in any of the AP is to find out the common difference and the first term. So what we will do, we'll make use of these two things to find out the first term and the common difference. So here, what is AP? So AP is, here we'll write the formula. AP is A plus P minus 1 into T. And this has been given, this is 1 by Q. Likewise, we'll find AQ. So AQ will be A plus Q minus 1 into D is equal to 1 upon P. So these two expressions we have got. So we'll just find the value of A and we'll find the value of common difference, and from there we'll find the value of APQ. This is because this is what our motive is. So in fact we have to prove that SPQ is half of PQ plus N. So we have to find SPQ. So we'll be finding SPQ instead. Okay, so these two terms are there, so we'll use this term. We'll simplify A plus P minus 1 into T. This is 1 upon Q. A plus Q minus 1 into T is equal to 1 upon P. So we'll just take the difference. The reason being the coefficient is same, so it can be easily subtracted. We'll take T common. So we have P minus 1 minus Q plus 1 is equal to, it will be 1 upon Q minus 1 upon P, and this cancels. So D is equal to P minus Q. We'll take LCM, PQ. This is P minus Q. So D is equal to, you can see both are same. So this cancels. The common difference is this, that is 1.1. Now here this value can be substituted in any of the equation, either this equation or this equation, to find the value of first term. So what we will do, A plus P minus 1 into D is equal to 1 upon Q. So A plus here P minus 1, this difference is 1 upon PQ. Okay, so we just open the bracket, A plus, and divide and separate. So you can see that if you simplify, this cancels, so we are left with 1 upon Q, which eventually cancels the other term. This get cancels. So it results that value of A is also PQ and value of D is also 1 upon PQ. Okay, now we have to find SPQ. Now we can use the formula, which is n by 2, 2A plus n minus 1 into D. So here your n is PQ. So SPQ here, SPQ is PQ upon 2, 2A plus PQ minus 1, and common difference is again this. Okay, A also, if you remember, is PQ. So PQ upon 2, A is 1 upon PQ. Okay, divide and separate. So we'll open the bracket. Okay, so here this is 2 upon PQ and this is 1 upon PQ. So if you take the difference, we get 1 upon PQ. Okay, so here we have PQ upon 2. This is 1 upon PQ plus PQ upon PQ. So PQ will be LCM. PQ upon 2, this is 1 plus PQ upon PQ. This cancels, and hence this was what we wanted to prove. And this is sum of first PQ terms. Thank you.